how different surfaces changed friction and distance of a ping pong ball. For the investigation, the research question is, how does surface type affect how far a ping pong ball rolls and the friction it experiences? For the goal, it is to see how different surfaces such as carpet, wood floor, and a blanket can affect the distance a ping pong ball rolls and how it is affected by the force of friction. For the prediction, I think in the ranking of carpet, blanket, then wood floor, the ball will have less force of friction and a farther displacement at the end of the ramp. For the background information, I included the motion and friction, initial velocity, acceleration, and the key equations. For the motion and friction, the equation is the force of friction equals the coefficient of friction times normal force. And then for the initial velocity, the ball leaves the ramp with an initial velocity that should remain the same for each trial. This ensures that the differences are due to the surface and not the ramp. The acceleration shows that the friction slows down the ball once on the flat surface, and this shows up as a negative acceleration on a velocity versus time graph. For investigating outside sources, I looked at the research others have done, which included using lightweight and heavyweight balls on different surfaces, as well as other sports, and finding the conservation of energy instead of the friction. They also vary the controlled variables for the same experiment, such as the angle of the ramp, type of ball, type of surface, distance the ball travels, and the length of the ramp. For motivation and context, I played ping pong throughout my entire life with my friends and my dad. Every time we moved the ping pong table from carpet to wood floors, I always remember how annoying it is when it bounces away compared to the carpet. This made me interested in how much that actually stops the ball in comparison to the surfaces. For the key terms, I have initial and final velocity, acceleration, force of friction, coefficient of friction, kinematics, and displacement. For this social and cultural investigation, ping pong is a sport that is widely played in many areas such as schools, community centers, and basements, and usually used to relieve stress or for social bonding. And in terms of popularity, over 900 million people watch ping pong tournaments globally, showing its massive effect on global communities. And as you can see on the picture on the left, it shows that it has increasing sales in the sports equipment industry. Surprisingly, for the summary of findings, the blanket took the longest time to reach the marker compared to the wooden carpet because it had the largest deceleration compared to the other surfaces, meaning that it was slowing down the fastest due to friction, and that resulted in it reaching the final marker in a slower amount of time. Next was the carpet, and then the wood floor. For the experimental design, I set up a ramp using a smooth cardboard box and then set up the measuring tape across the ground in order to calibrate the tracker software. Then I used a water bottle at roughly 29 inches in order to see how long it takes for the ping pong ball to cross that point at each surface. And as you can see, that's the marker on the picture. And then I set it up on each surface. And then for the controlled variables, it's the ramp angle, ramp height, starting position, recording distance, lighting, and camera angle. For the continuation of the experimental design, this shows all the data for the setup of the experiment, and in order to only focus on the friction of the surface and not the entire experiment, the friction force on the ramp is negligible due to the smooth surface of the cardboard and the consistent angle of the ramp. For the models and representations, it has two free body diagrams, one showing on the ramp and one showing on the ground. The only difference is on the ramp there's an angle, and then it also shows the system schema and the energy at rest, bottom of the ramp and on the surface. I first started with a secondary source investigation to see how this would compare to my experiment. I looked at another person rolling a ball on different surfaces to see the comparison in the pattern of how friction affects the ball. They rolled it on the carpet and concrete, and as you can see on the tracker, on the carpet has a higher deceleration and it took longer to reach the marker, therefore showing the same pattern as my experiment. For my tracker data, this shows a velocity time graph. Finding the line of best fit of this graph gives you the acceleration, and as you can see, this is showing for carpet. This is the tracker data for the blanket and the wood. This shows the tracker data, and it shows a table of the initial velocity, time, and acceleration for each of the blanket, carpet, and wood, and it shows that the blanket has a higher acceleration, meaning it slows down faster than the carpet and wood. For the data analysis and calculations, I found the final velocity, friction force, and coefficient of friction. For the final velocity, it shows the wood, blanket, and carpet final velocity, and the wood has the highest because it is going the fastest with the least amount of friction force. For the friction force, it is calculated that friction force equals mass times acceleration because the net force in the x direction is the same as the frictional force. And as you can see, the blanket has the highest friction force because it is having the most friction against the ping pong ball. This shows the calculation for the coefficient of rolling friction, and I said that the coefficient of friction equals the mass over gravity because the gravity equals the normal force, and the force of friction equals mass times acceleration. And as you can see, the blanket has the highest coefficient of friction. The table below shows these three calculations with uncertainty. This shows the uncertainty for the friction force and coefficient of friction. I used Tracker for finding the uncertainty of the acceleration, and I found these different uncertainties using the equations on the right. For scientific reasoning, first I start with discrepancies, and the first one is that it is uneven surfaces on the ground due to the carpet or the blanket. For bias, there is sometimes poor lighting making the ball's motion appear slower or faster on certain surfaces. For the sources of error, there could be a lack of accuracy in the tracker simulation and different initial velocities off the ramp due to systemic errors of ramp slightly tilted differently for each surface. And for the oversimplifications, I assume constant and negligible friction on ramp and no energy loss other than surface friction. So for the prediction and final result, my initial prediction was that in the rink and carpet, blanket, wood floor, the ball would have less force of friction and a farther displacement at the end of the ramp. But the actual results was that the blanket had the most friction acting on the ball, and then carpet, and then the wood floor. For future improvements, I think I could use more than 3 surfaces to improve results and create a ramp with more resources in order to keep the ball from bouncing on the wood floor as much, in order to keep the initial ramp velocity more consistent. Here are my sources.